All right, we're going to look today at lesson 3.4, which is on writing proofs. Really, we're going to work on two different ideas. We're going to work on being able to identify and interpret the differences between some of our base concepts that we'll be working with, terminology wise. And then we're also going to get into being able to justify proofs, being able to write the reasons given a proof that's been presented. So we're just getting into looking at how we do proofs. We're not going to write any on our own. It's going to be all set up for us, and we'll work off of that. All right, so first of all, we want to look at some key concepts here, what they mean, and then we're going to be able to separate or identify the differences between them. So the first thing is that of a definition. A definition is simply a statement that's been proven true by accepted arguments, and it is the formal statement that describes what a term is. For instance, the midpoint of a line segment is a segment or is a point that divides a segment into two congruent segments. That's a definition. Okay. The next idea is conjecture. And a conjecture is a statement that may be proven, or excuse me, may be true, but has not been proven yet. It's an educated guess that's based on known information, based on patterns. It comes from inductive reasoning. It has never been verified, but it also hasn't been proven false. It's just that it's an educated guess right now. A postulate is a statement that's accepted as true without proof. So there's the key. You don't have to prove it. We accept it to be true without having to prove it. All right. And we use this to help prove other statements, and often it's part of a theory. Okay. A theorem is a statement that has been proven true. So a theorem is like starting with the conjecture and then proving it true by accepted statements and arguments. All right. And once it's been deduced, or excuse me, it gets deduced from definitions, postulates, and other theorems. Okay. But once we prove a conjecture true by an argument here, it becomes a theorem. And then an undefined term. This is a term that's not given any formal definition. And in geometry, there are three key undefined terms: the point, the line, and the plane. These are concepts. All right. You can't actually draw a point, a line, or a plane because these guys are conceptually too detailed to even put down. For instance, a point just shows a location. It's a speck. As soon as you make a big dot on your paper, you've just you've included an infinite number of points. So you can represent it, but you can't really draw it. Line, plane, same idea. So these are the three undefined terms of geometry. All right. So what we're going to do first of all, and the questions you're going to work tonight are going to be giving you a situation, asking you which of our five key concepts does it represent. So, for example, Jane wrote a proof that included a statement about lines. Line is the best defined as what? Well, a line, we just talked about this one. A line is one of the three undefined terms of geometry. So, if we're going to talk about a line, we're talking about an undefined term. Another example. Okay, Kayla claimed that a certain statement about a polynomial function is true. The statement has never been proven true. So she's claiming a statement to be true, but it's never been proven true. So the best description for this scenario is a conjecture. Okay. It's a remember, conjecture is a statement that we think is going to be true, but we haven't proven it true yet. So this is a conjecture. Okay. Next one. Dan believes that that a certain statement about right triangles is true, although there is no proof that the statement is true. So he thinks a statement is true, but it isn't been proven yet or hasn't been proven yet. Therefore, again, we're dealing with a conjecture. Okay, another one. Amy claimed that a certain statement about rational numbers is true. She was then able to prove that the statement is true. So she made a claim and then she was able to prove it. Which one is that? Well, if you make a claim and then you can prove it to be true, you got a theorem. Okay, couple more. Josh read a proof that included a certain statement. The statement is not a definition, but it is accepted true without being proven true. Which of our terms did we say are accepted true without having to be proven true? That's a postulate. Last year, Ashley guessed that a certain statement about prime numbers is true. She then found a proof that the statement is true. So she made a guess and then she found proof that it is true. So that's a theorem. Okay. So guys, have these definitions written in your notes and then just, reference them to make the right choices here. Okay. The next idea we're going to move to is actually writing proofs. So we're going to use the ideas that we just talked about, and we're going to look at how they apply to proofs. All right, when we write a proof, it's going to be a two-column proof. And this is a type of proof that uses conjectures and theorems. And then when we number the steps that contain the statements that are going to lead to our conclusion, and then we list the reason for each step, and we do this in two columns. Okay. The properties that we've already worked with, some in class that we've already talked about, others we'll continue to bring in, they're going to be used as the reasons for these given statements. Okay. So let's look at a two-column proof. So this is a look at a two-column proof. All right. So here's the given material. So they give us this drawing. They tell us that one of the given facts that we can use is that BD is equal to CE. Our job is to prove that BC equals DE. Whatever you're trying to prove is going to be the last statement in your proof. This should be your final conclusion. Okay. So what we need to do is there's going to be, for the reasons here, there's going to be a little pop-up box, and it's going to give you these choices. All right. And then you choose from these which ones go here for the reasons. All right. So let's take a look at this thing. So first thing it says is that BD is equal to BC plus CD. So go up here and look. B to D is equal to B to C plus C to D. Okay. Well, hopefully you remember this is the segment addition property. The segment BC plus the segment CD is equal to the overall length BD. We've worked that before. Next step, CE equals CD plus DE. So here's CE, this full length, and we're saying it equals CD plus DE. So the two segments add up to this entire segment. That is, again, the segment addition property. The next line, BD equals CE. Hopefully you remember this. It was a given. So we just write given. They told us that fact. We didn't have to prove it. Okay, continuing. BD or BC plus CD equals CD plus DE. Now, where did this come from? Well, it comes from combining these three steps above. You see how we got BD here, and up here BD equals BC plus CD? So since BD is equal to this sum, I can put this sum in place of BD. Since CE equals this sum, in place of this CE, I can put the sum. So this is substitution. And then you'll notice how we got a CD on each side. Remember, these represent numbers here. So we're using all of our basic equality properties. So I want to get BC equals DE. I want the BC and the DE to be remaining on the sides. So what I want to do is subtract CD from both sides, and that will leave me with BC equals DE. This is a very common proof. Okay, this process that they've used of substitution and segment addition and so forth. We will use this a lot, but that's how we do it. We gotta read the statement, figure out where it came from, what allowed them to make that conclusion, and then choose the correct reason. Okay, let's do another one here. So we got this big drawing given to us up here. Okay, don't let that intimidate you. All right, we are given that PQR, this angle PQR, is equal to this angle TSR. We're also told that angle 2 and angle 4 are equal. We're supposed to prove 1 and 3 are equal. Okay, well, you don't have to worry about how to figure that out. They figured it out. We just got to justify what happened. So again, you'll have a pop-up box here, and we got to fill these in. So let's start with our first statement. The measure of PQR equals the measure of 1 plus the measure of angle 2. So PQR, the overall angle, is equal to the sum of the two angles that are inside that angle. Hopefully you see that as angle addition property. Okay, angle TSR is equal to angle 3 plus angle 4. 3 plus 4 equals TSR. That's the same thing, angle addition property. The two small angles add together to make the big. Okay, the measure of angle PQR equals the measure of angle TSR. That's right up here in the given. Okay, next statement, very similar to the last proof. The reason that we entered this in now is because look what we have above. I have the measure of 1 plus the measure of angle 2 is equal to PQR. So in place of this PQR, I'm going to put the measure of angle 1 plus measure of angle 2. Measure of angle 3 plus measure of angle 4 is equal to TSR. So in place of this TSR, I'm going to substitute in what it equals, which is the measure of angle 3 plus 4. So this line comes from a substitution. Measure of angle 2 equals measure of angle 4 up here is a given. Okay, so that's a given. Now look at look at statement 4 and statement 6. Tell me what's the difference. Statement 4 and statement 6. Hopefully you recognize that this measure of angle 2 has been replaced with the measure of angle 4. Well, that comes from line 5. Angle 2 and angle 4 are equal to each other, so I can replace this measure of angle 2 with the measure of angle 4. That's substitution. Now you'll notice I got a measure of angle 4 on each side of the equal sign. So if I subtract the measure of angle 4 from both sides, I'll have my final answer. Once you do a few of these, you'll see the pattern with this. Okay, let's do one more. Again, I have some angles given to me. I'm given information about them. So angle AXC down here, AXC is equal to DZF. Angle 2 and angle 4 are equal to each other. We got to prove 1 and 3 equal to each other. You start to see this after you do a few of these. So again, pop-up box will come up here, the measure of angle AXC. So AXC is this angle, and it says it equals the measure of angle 1 plus the measure of angle 2. That's angle addition. DZF equals measure of angle 3 plus measure of angle 4. Okay, angle addition property. Measure of AXC equals a measure of angle DZF. Where's that come from? Up right here. It was a given. Now, this statement, just like in the last problem, AXC equals a measure of angle 1 plus a measure of angle 2. So in place of this AXC in line 3, I'm going to put measure of angle 1 plus measure of angle 2 because it equals that. In place of this measure of angle DZF, I'm going to put the measure of angle 3 plus measure of angle 4 because DZF equals that, the sum of those two. So that's substitution. Next line, angle 2 equals measure of angle 4. That was a given. Okay, again, if you look at line 4 and line 6, the difference is this measure of angle 2 is now the measure of angle 4. We got that by substitution using line 5. And then I'm going to subtract the measure of angle 4 from both sides, and I got my final answer. Okay, so you're going to get questions like that tonight. You're going to get questions that deal with, identifying terms, determining which is the best description of that statement, and then you're going to have to fill in some of the lines for proofs. Okay. Well, hopefully you took down some notes, have some ideas, some examples to work from, and I will let you get started.